Hi everyone, we're back with a new video on increasing, decreasing, and constant functions. So I'm actually going to just use one example that combines all three of these concepts together because it creates a very good analogy for understanding how functions increase, decrease, and are constant. So let's think of the intuitive part first. So let's get, let's stay with that color. So say we have a person standing at this point right here, and imagine that this function is the ground. So, dot, 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 dot. So the person can't go under the graph. You're walking on the graph as we're going. The idea of, and then the other thing we have to draw, and I'll draw it in a different color, is I left off the y-axis initially because we want to think of this more as the person walking on, walking over terrain. So maybe there's like some town or house over here that the person is trying to get to. And let's put a little smokestack, dot, dot, dot. I know my art's not the best. So the x values represent the position that the person is at, and then the y values are going to represent the height, let's say above sea level, that the person is at. And the idea of increasing and decreasing functions is if you're increasing, then your height above sea level is increasing. If you are decreasing, then your height above sea level is getting smaller. And if you're constant, then your height above sea level is not changing. So the first thing to notice is as this person changes from, let's draw this in green, as this person changes from -11 to -5 in position, so we're on this interval, what happens? Well, this person is getting higher and higher. I apologize for that, but we'll plug that battery in as soon as we're done here, and all the way up to the top of the hill at x equals 5, or x equals -5, and so we say that we are increasing on -11 to -5. Well, next, notice that once we hit the peak of the hill, there's only you can only go down. So, from -5 to 0, notice that my person is now going down the hill. So we keep going that way, we're going down the hill, we keep going down that way until we get to this low point right here at x equals 0. So once we're at the location x equals 0, we're at this kind of part where the height levels out. And so on this interval, we are decreasing. But notice now that as I am at the location 0 to 6, let me get a different color here. Let's do brown. Haven't tried that one yet in the video. So we're going here from 0 to 6, so we're on the interval 0 to 6. Notice that my person is staying relatively level compared to sea level here. So we're walking this way, we're walking this way, and we're walking until we get to this point at x equals 6, where now we have a very steep decline. So again, this is where we're going to be constant. So notice that the idea here is that I've never said anything about the y values. You notice I'm consciously not talking about the y values. I am only talking about the x values. And that's because we're really interested in the positions that have these behaviors. We're not actually interested in the actual height. We're just actually interested in the positions. So to continue this analogy here, on this interval, so let's do this in purple. So from 6 to 10, notice that this person is now going down the hill, and this is pretty steep, so maybe he's going to sit down and, slide down the hill, yay, until he gets all the way down here to the bottom. So now he is at the valley at x equals 10, and so notice that his height is decreasing, so we say that on this interval on these positions that his x values or on these x values his height is decreasing. And then finally on the last interval, this person starts going up the hill, up the hill, up the hill. And notice that because we have this arrow here, if this person keeps on walking in this direction, this person just is gonna keep on walking up and up. And so from, let's do red, from 10 to infinity, then we're going to say that this person is increasing in height. Of course, in real life, there would be some peak, but since this is the theoretical math graph, we can assume that this person is going to climb this hill forever and ever unless this person stops walking. So this is the idea of increasing, decreasing constant functions. Is we look for the x intervals where we are increasing in height, or the x intervals where we're decreasing in height, or the x values where we're our height is constant, and we don't actually care about the height itself. So I hope this helps clear up what increasing, decreasing, and constant are. So just keep this hill climbing analogy in your back of your head, and you should do fine on this. And this topic does come up. This is a college algebra topic. We're talking about it again. You will talk about it in calculus. So this is something you definitely need to get down. Now I'm going to plug my battery in, so I will see you